Good morning and welcome to this next lecture on vibrations of plates and shells. So last time we derived expressions for normal strain epsilon II and shear strain epsilon ij. So today I will actually derive an expression for epsilon 11. Okay. So what did we say? Epsilon II is 1/2 GII minus GII by small gii. Okay. So let us see what we are going to do here. We have epsilon 11. Epsilon 11 is equal to 1/2 and then G11 plus del G11 by del alpha 1 xi 1 plus del G11 del alpha 2 xi 2. I am straight away using the formula del G11 by del alpha 3 xi 3 plus twice G11 del xi 1 del alpha 1, okay, minus G11 divided by G11. Okay, so now this G11 cancels with that G11. So let us see, we have G11 given by A1 squared 1 plus alpha 3 by R1 whole square. Okay. So from here del G11 by del alpha 1 is equal to twice A1 1 plus alpha 3 by R1 del alpha 1 A1 into one plus alpha 3 by R1, okay, del G11 by del alpha 2 is equal to twice A1 1 plus alpha 3 by R1 del alpha 2 A1 1 plus alpha 3 by R1 del G11 by del alpha 3 is equal to twice A1 1 plus alpha 3 by R1 del alpha 3 A1 1 plus alpha 3 by R1. Okay. So now let us see. We have to bring all of this into here. So epsilon 11 is given by 1/2, okay, 1/2, then let's see, twice, okay, root G11, okay, which is this, del alpha 1, del alpha 1, A1 1 plus alpha 3 by R1. Xi 1 I am going to write as U1 by root G11. Okay, U1 is the actual displacement which is given by, okay, root of G11 into the coordinate change, if you remember, not I1. You remember this, okay. Then plus twice root G11 del alpha 2 A1 1 plus alpha 3 by R1, U2 displacement in the 2 direction, root of G22, okay, plus twice root G11 del alpha 3 A1 1 plus alpha 3 by R1, U3 by root G33. G33 is 1, if you remember, small G33 is equal to 1. So, this is U3. Okay, plus twice G11 del xi 1 by del alpha 1 slash G11 divided by G11, this G11. Okay. So, what shall we do? What we do is, everywhere there is a 2 first, so we can take it out. This 2 goes with that 2, goes with that 2, this and this 2 goes away, okay. And everywhere there is a, here there is a root G11, root G11, root G11, and this is G11, okay. So, we get epsilon 11 is equal to del alpha 1 A1 1 plus alpha 3 by R1 U1, this goes with that, okay. So, let me put a big bracket here. Then I have plus root G11 by root G22 del alpha 2 A1 1 plus alpha 3 by R1 U2 plus root over G11 del alpha 3. Let me make it simple right here. In the alpha 3 direction there is no dependence because we are talking thin shells. I will come to this point. Okay, let me write it for now. Del alpha 3 A1 1 plus alpha 3 by R1 U3 plus G11. Okay, now I will do this over here. Xi1 is del del alpha 1. Xi1 from here is u1 by root G11. Okay, and then divided by G11. Okay, so let's see what we get. We will get 1 over G11, 1 by G11 in front, this G11 in front, U1 del alpha 1, A1 1 plus alpha 3 by R1, okay, plus del alpha 2. So this is important here. So let us see, del of del alpha 2, A1 1 plus alpha 3 by R1. Okay, if you recall, what is that? That's our Gauss Codazzi relation. Okay, that is equal to 1 plus alpha 3 by R2 del A1 by del alpha 2. Okay, so that is our Gauss Codazzi relation. So what we get? We get, if I write A1 1 plus alpha 3 by R1 and A2 1 plus alpha 3 by R2, this is root G1 by root G2 2. Okay, then del alpha 2 of this is 1 plus alpha 3 by R2 del A1 by del alpha 2. Okay, so then this goes away. Okay, and here in this term, so this is just the explanation, okay, in here now I have plus root G11, A1 and A2 are functions of alpha 1 alpha 2 only, surface properties, okay, not of alpha 3. So what we get is A1 by R1 into U3 for this term, okay, plus G11. Okay, so one term is going to be root of G11 del alpha 1 of U1. Okay, and the other term is going to be, I will take it as this as one term, okay, like 1 over z. So what will, if I take that to be 1 over z, ignore the square root for the moment, what I will get is plus G11 U1 into minus 1 by z square, which is G11, okay, del by del alpha 1 of z1 z, which is square root of G11, and then we close this bracket. Okay, so let us see this leads to a square root in the numerator. This leads to a total cancellation. Okay, so what now I get here, there is a u2 first of all here, u2. Okay, so if I write that, this is going to look like this: 1 by g11 u1 del by del alpha 1 a1 1 plus alpha 3 by r1 plus a1 by a2 1 plus alpha 3 by r1 del a1 by del alpha 2 u2, then square root g11 a1 by r1 u3 plus square root of g11 del u1 by del alpha 1 minus u1 del alpha 1 square root of g11. Okay, so to remind ourselves, this term here is root g11. Okay, so if I write it that way, I have 1 over g11 u1 del alpha 1 square root of g11 plus a1 by a2 1 plus alpha 3 by r1 del a1 by del alpha 2 u2 plus root over g11 a1 by r1 u3 plus square root of g11 del u1 by del alpha 1 minus u1 del alpha 1 square root of g11. So this term is the same as that term. Okay, and then this term is again square root of g11. So we have square root of g11 here, here and here. So if we combine, I get 1 over square root of g11 u2 by a2 del a1 by del alpha 2 plus a1 by r1 u3 plus del u1 by del alpha 1. This is my epsilon 1 1. Okay. Now we need to make another assumption over here. Before that, let me just write down. I will not derive for every epsilon. Okay, so this is epsilon 1 1. So symmetrically, I get 1 over square root of g22 u1 by a1 del a2 by del alpha 1 plus A2 by R2 U3 plus del U2 by del alpha 2 okay, that is epsilon 2 2 then epsilon 3 3 is del of U3 by del alpha 3 epsilon 1 2 is equal to A1 1 plus alpha 3 by R1 by A2 1 plus alpha 3 by R2 del alpha 2 U1 by A1 into 1 plus alpha 3 by R1 plus A2 by A1 1 plus alpha 3 by R2 1 plus alpha 3 by R1 del alpha 1 U2 by A2 1 plus alpha 3 by R2 and epsilon 1 3 is A1 1 plus alpha 3 by R1 del alpha 3 U1 by A1 1 plus alpha 3 by R1 plus 1 by A1 1 plus alpha 3 by R1 del U3 by del alpha 1 epsilon 2 3 is equal to A2 1 plus alpha 3 by R2 del alpha 3 U2 by A2 into 1 plus alpha 3 by R2 plus 1 by A2 1 plus alpha 3 by R2 del U3 by del alpha 2. Okay, if you follow the procedure. And the Gauss Codazzi relations have been used. Okay, like in this term, the Gauss Codazzi relation has been used. Okay, so time is running out. I will stop here. Thank you.